Let's compare the Bohr and the wave model of the electron. Here is the Bohr model of the electron. We see that it exists. It exists in shells. It is very small, checking in at about 10 to the minus 18th meters. This is perhaps the size at which matter coalesces with energy. Too small to be a thing, if you will. It exists near a nucleus, not very near, but there is a nucleus there, and the nucleus is about 1,000 times larger, about a femtometer. All of this is what comprises an atom, in this case a hydrogen atom. And if you look at the difference between this size, 10 to the minus 15th meter, and the size of the atom overall, which is a nanometer, well, there's like 6 orders of magnitude or 1,000,000 times empty space here, which is something Rutherford alluded to, that the atom is mostly just empty space. That's a lot of empty space between there and there. Okay, so that's the Bohr model of the hydrogen atom. But if you look at the quantum mechanical or the wave model of the atom, we know that it's still, the electron is located outside the nucleus. This is the model that I'm going to use to give you some kind of idea of what it looks like. Those electrons exist in shells, kind of like this, but not simply just an orbiting like dot. They're in subshells as well. I can see some p orbitals here. And there's S, P, D, F, and beyond once we get some larger elements going. They exist in orbitals, meaning that they pair up within these subshells. The p orbital group consists of 3 orbitals, for example, and those pairs tend to have opposite spins. This is typically represented as spin up and spin down. We also know that the electron is believed to be an elementary particle, meaning you cannot cut it in half, get any smaller. There's no gluons in it, no nothing. It's just an electron. And we should mention the mass of it, even though mass of something that isn't quite a thing must be a kind of gray area. But it doesn't have much mass. It's estimated at 10 to the minus 28 grams, which is about 2,000 times lighter than a proton. There we are. This is the electron configuration working its way out to the very large elements. I think I'll stop there. Okay, that was a little bit of a comparison between the Bohr model and the quantum mechanical model of the electron.